Hi there, I'm Mr.Azeez. I'm doing math videos. In this video, we are going to show that gamma of n+1 is equal to n.Gama of n. We begin with the gamma function's definition. The definition is like this: gamma of n is equal to integral from 0 to infinity t to the power of n minus 1. So whatever we have in here, it's to the power of n minus 1. And then e to the power of negative t, then dt. In this integral, t is the variable, n is just a constant. Okay, so we begin with the left-hand side. Here we have gamma of n+1. So in this formula, in place of n, we write n+1 and see how it looks. We will have gamma of n+1. Then it's going to be integral from 0 to infinity. T to the power of, in place of n, I'm going to write n+1, and this minus 1 is already there. It's a part of the rule. E to the power of negative t, there is no any n, and dt. So this is the formula of gamma of n+1. Now we are going to solve this integral, and the next step, to solve this integral, we cannot solve it directly, so we're going to use UDV. In the UDV part, we let u be equal to t to the power of n. Why power of n? Because this plus 1 and minus 1, they just cancel each other, so only t to the power of n is remaining. This is u. And after that we have dv, and we let dv be the rest of the integral, e to the power of negative t dt. Okay, this is u, we need du, and it's obvious du, the power goes to the front, power minus 1, so it's going to be n t n minus 1, and this is dv, this is derivative. We need to integral this to get v back. So v is negative e to the power of negative t. So you can just solve this as an integral problem, and simply you get that. Now we apply the rule of UDV, then we will have UV, so it's t to the power of n, UV negative e to the power of negative t. So this minus here belongs to this one, but it's better to write it outside like this. And it's from 0 to infinity minus integral from 0 to infinity uv minus integral v du. So that's going to be like this. V is v du, but we write this n is a constant. It will go out because our variable is t, n is a constant, it will go out. So we have t n minus 1. We have this e is negative. This negative also goes out of the integral, so this negative right here will make this negative positive. Now n t n minus 1 e negative t dt. This dt is this one. We have something that we can simplify. Well, if we look at this formula looks like the formula of gamma of n. Well, we can just write, in place of this shaded formula, we can just write gamma of n. This is gamma of n. This n is outside and it's multiplied by gamma of n. So this n will be n gamma of n. Okay, this part became n gamma of n. So far, easy. And what happens to this part, it's going to be 0. Because when we substitute 0 in place of t, this side will be 0, and 0 times e will be 0. And when we substitute infinity in place of t, using limit, using L'Hopital rule, we can figure out the limit of this one at infinity is 0. So 0 minus 0 is equal to 0. So this part is 0. Okay. So what we did, we began with the left-hand side, and we worked out the right-hand side. That's it. Thank you for watching.